Today, we are starting Unit 4 of Data Structure, that is tree. Trees are one of the most important nonlinear data structure used in file system, database, artificial intelligence, and compilers. In this lecture, we will cover what is tree, definition of tree, tree terminologies, and tree representation. By the end of this video, you will clearly understand how trees are formed and how data is stored in a tree. Now, what is tree? A tree is a way of organizing data in a hierarchical form. Hierarchical means one element is above and others are below it, such as organizational chart, folder structure in computer, family tree. All of these are the tree structure. Definition of trees. A tree is a collection of nodes connected by edges. Each node stores data and linked to other nodes. Unlike array or linked list, a tree does not store data in a straight line. It has parent and child relationship. Now, some important tree terminologies. First one is root node. The topmost node is called as a root node. It is starting point of the tree and every tree has only one root. Here, A is the root node. Edge. In tree, the connecting link between any two nodes is called as edge. Here, a link joining A and C, it is a edge. And A to B, it is also edge. Likewise, every two nodes are connected with the edges. Parent node. In a tree, the node which is a predecessor of any node is called as a parent node. In simple word, the node which has branched from it to other node is called as a parent node. Here, A, B, C, E, G are the parent node. Child node. A tree in a data structure which in the node which is descendant of any node is called as a child node. The node which has a link from its parent node is called as a child node. Here B and C are the children of A and G and H are the children of C. Here K is a child of G. Siblings. Nodes having same parent are called siblings. Here B and C are the siblings, whereas D, E, F are siblings, G, H are siblings, I, J are the siblings. Leaf node. The node which do not have any children are called as a leaf node. Here D, I, J, F, K, H are the leaf nodes. Internal nodes. The nodes which have at least one child are called as an internal node. Here A, B, C, E, G are the internal nodes. Degree. The number of children of a node is called its degree. Degree of tree equal to highest degree of any node. Here degree of B is 3 and degree of A is 2. Here degree of F is 0. In any tree, degree of node is total number of children it has. If we want to discover, we want to know the degree of the tree, the highest degree of a node among all the nodes is in a tree. It's called as a degree of tree. Here, degree of tree is a 3. Level. Root is at level 0 and its children are at level 1 and their children are at level 2 and so on. Height. Height is the number of edges from a node to the deepest leaf. Height of the tree is the height of the root. Here, for B, the height is 2. For A, the height is 3. For K, height is 0. For G, H, F, E, D, the height is 1. Sorry, E, G, height is 1. Depth. Sorry. Depth of node is the number of edges from root to that node. Here, depth of A is 0 and depth of B and C is 1, whereas E and G has 2, D has 2, F has 2, H has 2, I, J and K has depth of 3. Path. A path is a sequence of nodes connected by edges. A path is a sequence of nodes connected by edges. Here, for if we want to traverse from A to J, then path will be A, B, E, J. If we want to traverse C to K, then path will be C, G, and K. Subtree. Any node along with its children form a subtree. C. B. Here is one left subtree and one is right subtree. These are the diagrammatic form of tree terminologies. The root is shown with a red arrow, which is the parent for B and C. B is a left child, whereas C is a right child. D, E are the siblings, as they are from the same parent B. And F and G are siblings, as they are from the same parent C. B, D, E they become uh, they become subtree, and C, F, G become a right subtree, whereas D, E, F, G are the leaf nodes. This is a summary for the tree terminologies. Now, let's see the tree representation. A tree data structure can be represented in two methods. List representation, left child, right sibling representation. These are used to store trees efficiently in a computers. List representation. As you see, we use two types of node, one for representing the node with the data called as data node and another for representing only reference called as a reference node. We start with a data node from the root node in the tree. Then it is linked with the internal node through the reference node, which is further linked to any other node directly. And this process repeats for all nodes in a tree. Here we can represent the tree for the tree shown below as a list representation. Left child, right sibling representation. We use list with one type of node which consists of three fields, namely data field, left child reference field, and right sibling reference field. Data field store the actual value of node, and left reference field store the address of the left child, and right reference field store the address of the right sibling tree. If the left child node or right sibling node has the leaf node, then it will store the null value. Here is the example for the tree represented using left child and right sibling representation are as follow. Thank you.